Thanks very much, Mary Beth, and thanks to Kevin and the team for inviting me here to talk about what has, I guess, gone from being an obsession to a full-blown sort of career, which I guess is, I think is kind of fun, and certainly I'm very privileged and lucky to be able to do that. What I'm going to do today is talk to you about, I'm going to sort of give you a tour, if you will. I'm going to give you a tour of scientific publishing. Now, I just want to say a couple things about that. First is that, you know, although I recently moved, my wife and I recently moved, we used to live in New York, and where I still teach. And so, you know, you may be familiar when you go to New York or pretty much any large city nowadays. They have these double-decker buses, and you get on the bus, and they show you all the highlights. And at some point in the tour, because there are these, at least in New York, there are these glass buses with domes on them. And apparently, those of us who live in New York are supposed to wave at everybody who's in the bus because they're supposed to wave back. We do wave, or I should say we use gestures with our hands that it's New York. We want them to get the full experience. So, not all kidding aside, I try and kid because I think that a little bit of humor with this stuff makes medicine go down, so to speak. But this is not a tour of the highlights of scientific publishing. This is more like a tour if you showed up to London and you wanted to go on a tour and they said, oh, here's one, here's this Jack the Ripper tour, and you're supposed to show up in an alley around midnight, a very dark alley that you can't quite find, and nobody would be able to find you if you didn't come back. It's a little bit more like that tour, and by the way, since I am, although I'm not a licensed doctor and I'm certainly not board certified and don't practice medicine, in case any of this is taken as medical advice, let me just say don't sign up for that tour in case you were considering it. So that's what I'm going to do today, and just listening to this morning's presentations already and thinking a lot about the work that Health Watch USA does, I want to draw a couple parallels just to maybe because I think it's always useful. What I'm talking about is related, but in many ways tangential, if you will, if I may be honest, to the important and critical work that many and all of you probably in this room do about patient safety and about these related issues. It is related in ways that I'll explain, but I just want to sort of plant the seed that what we're looking at in terms of retractions in particular. Adam and I co-founded Retraction Watch about 7 years ago now, August 2010, and at the time we were two journalists who saw a really good source of stories. I was talking to Lee Tilson, who was very kind, picked me up from the airport last night, and I said, you know, the reason he's asked me why we launched it, and the reason was that, if I may, in a way that, same way that attorneys are always looking for cases, you're kind of looking for singular cases that may turn into something bigger, but that are at their core cases with real people involved. Well, that's what retractions were for us in terms of being journalists. When you're a journalist and you can see all sorts of stories that are kind of hiding in plain sight, which is what retractions are, especially when so many of them include fraud and involve fraud, it's catnip. It's just like, it's what we wanted to do. And so what we didn't know was that the problem was much, much bigger than we thought it was. But I also want to say that if you think about it, and we're building a database which is just about complete, and I'm going to talk about it a little bit today, of retractions. Most comprehensive database there is, for reasons I'll explain. But it's a bit like an adverse event reporting database, if I may. So yes, these are the ones that got caught. These are the ones that somebody reported. These are the ones that actually something happened because it happened. Something actually showed up in the literature. We're dealing with an iceberg, whatever metaphor you want to use, and I think that there's an interesting parallel there. So I will shut up with my sort of rambling general comments and actually get to what I wanted to talk to you about today. So I don't know how many of you can sort of actually see what's on the screen. I'll try and describe it for those of you who can't. But this is a screenshot of a paper that's published, and I guess, I apologize, one more just little sort of asterisk note. Retraction Watch covers all of science. In fact, we cover all of the scholarly literature. So what you're going to see today, you're actually not going to see all that much clinical research represented. I just want to sort of warn you about that because I know that that's the main focus here is clinical work, clinical medicine, etc. That doesn't mean, and there are some reasons why actually clinical medicine, if anything, is underrepresented among retractions, which I'll talk about briefly. But my point here is that just because you don't see it here doesn't mean there aren't problems there. We cover everything from, as we like to say, physiology to physics. And so you're going to see lots and lots of different things, although you will see some clinical medicine. So with that is another, apologies for the preamble there. This is the Journal of Computer Science and Information Technology, not, I imagine, a journal that's on too many of your radars. But it looks a lot like a journal. It's not a really great-looking journal, to be honest. It's not, no, I don't think anyone with a degree in design actually had anything to do with what this page looks like. But it has all the trappings of a journal, right? So it's got a title. That's a good start. It has the title of the article, authors, abstract. It's got these things that look official. They actually are official. The things like DOI, Digital Object Identifier, ISSN, that means the Library of Congress has actually sort of signed off, not on the fact that this is a quality journal, just on the fact that it exists. Somebody filled out the paperwork. Good for them. So, you know, it looks legit. And since you wouldn't necessarily know this journal, and I certainly wouldn't, you might look at it and go, okay, looks like a journal. That's great. But I'd like to draw your attention to something that, I guess in a vague sense, is sort of clinical. This is actually the title of the article, and these are the authors of the article. And I can usually tell when I show this slide how much coffee people have had, because as there are now, there's some chuckles. I think you all have good senses of humor, so I'm going to guess that you just haven't had enough coffee, which is a great sort of justification if you don't laugh at any of my jokes, too. So thank you. So robots no longer considered harmful. Now, you may, and this, by the way, had nothing to do with like Da Vinci surgery robots or anything like that, which you probably all know a lot about. This was, you know, this, if you didn't know this field, you might say, well, maybe that's a sort of pressing issue in scientific research. Maybe this is a pressing issue in robot studies. Isaac Asimov started a revolution or something like that. So maybe that wouldn't throw you so much. But when you look at the author list, which apparently some of you have, you see the very famous, really famous urologist, Dr. I.P. Freely. I think I ran into him in the men's room a few minutes ago. You know, he works sometimes with Oliver Clozoff and their famous French colleague, Jockstrap. Now, these are obviously not real people, or at least I hope you all find it obvious that they're not real people. They are. Anyone know actually that they're actually from somewhere? Anyone know what this list of authors comes from? This little, I think I heard it somewhere. There's a little show called The Simpsons, and these are actually all Simpsons characters. Now, why do I show you this slide other than it being funny and me trying to see if anyone's paying attention? It highlights a few different things. One of which is sort of fun, and the other one is not so much fun. I'll give you the not so much one first, so you'll have to wait with bated breath for the fun one. The not so fun thing is that what you are looking at is what's known as a predatory journal. Now that terminology is a little bit controversial, but I'm going to stick with it today because it's kind of in common usage, people understand it. A predatory journal is a journal that looks a heck of a lot like a real journal. It's got all the trappings, it's got everything. If you didn't know better, you'd look at it and think it was a real journal, but actually isn't really a real journal. What it is a cash cow for a very unscrupulous, and I would even argue fraudulent, publisher. So they will take your money to publish this paper, but they won't actually peer review it. Anybody would have peer reviewed. And by the way, and I'll get to the funny part in a second, which will explain why, this paper looks a lot like a paper until you actually read it, right? Until you actually look at the images, the figures. So you've got figures where, you know, the X and Y axis are the same. Now, I don't know how much research any of you have done. I think some of you have done a lot of research. We heard about some just now. I think you're pretty comfortable with the idea that the axes of a particular figure should probably be different, right? And you'll see things where a circle sort of goes back on itself like a snake eating its own tail. There's not a lot of sort of sense that would make in a sort of scientific finding. I may not be articulating that well, but I think if you look at the paper, you'd see what I mean. And you can look at it. It's online. These are publishers that have sprung up to take advantage of what they're called predatory, to take advantage of researchers who have to publish or perish. And that's going to be a theme today of, I think, of my talk, which is that a lot of what we're dealing with, you know, what we heard just now about, it's not about a particular nurse or a doctor or what have you. It's about a systemic issue. It's about some sort of problem in the system. And one of the problems in the system, which, to be honest, came out of a very good intention, an excellent intention to make the literature freely available to everyone is that one of the business models for making the literature freely available to everyone is that instead of paying subscription fees, right, to where a library, university, or yourselves individually pay some sort of fee to read, in fact, the authors are paying a fee to publish. Now, a lot of people say, well, automatically that means it's vanity press. I would actually disagree with that quite strongly, and happy to talk about it further if there are questions. But there are legitimate publishers, open access publishers, that use that model, and then there are a lot of illegitimate, in fact, at last count, far over 1,000 illegitimate publishers that use this model. Now, again, I won't get into too many details here. Happy to answer some questions later if you'd like. And there's someone named Jeffrey Beal. He still is a librarian at University of Colorado in Denver, but he no longer publishes his list for various reasons, which only he knows actually. But that's where you can find it. You can actually find it on the web archive, but if you Google Beal's list, you'll find again a list of more than 1,000 publishers, each of which has an average of say 20 journals. You're talking about thousands of journals, tens of thousands of journals that they're fake. I mean, they're actually fake. Yeah, they exist. I don't think I have to tell you that the fact that somebody stands up, particularly at a podium, and says something, it's true in that that person said it. It didn't actually, it's not a real statement, it's not fake, it's fake. And then the fun part, right, which is how this particular paper got published. Anyone ever heard of Alan Sokal, the Sokal hoax? Okay. So Alan Sokal, who, I call him a colleague because he also teaches at NYU, but that's like, I mean, he's the real NYU professor. I'm just a guy who shows up and does some stuff. Sokal is a mathematician and physicist who, in the late 90s, he was getting kind of fed up with what he was reading in a lot of the sort of, if you will, postmodern, like, sort of literature, scholarly literature, humanities in particular. And he just felt like a lot of it was just mumbo-jumbo junk. And so he wanted to see if he could just write something that was mumbo-jumbo junk and get it published in one of the top journals, and guess what, he could. He wrote a whole book about it, which I would heartily recommend. This is now referred to as the Sokal hoax. That's not the name of the book. Apologies for not having it on top of my head, but it's Sokal. You can find it quite easily. And so what happened was a group of graduate students, computer science graduate students at MIT, in 2005, they came up with a way to, if you will, industrialize the Sokal hoax, to mechanize the hoax. And so they created a site called, maybe some of you have heard of, called Scigen, S-C-I-G-E-N. Anyone ever heard of Scigen? Okay, wow, I'm just dropping massive knowledge this morning. It's fantastic. I could make up some other stuff. No. So you Google Scigen, and I never remember the URL of that exactly, but it's Scigen MIT. It'll get you there. You can actually go there and type in, all you need to do to write a paper. Adam and I have done this. In fact, we have a paper that's on my desktop of that our dogs have written. It's some of the best work on robots by dogs by far I've ever seen. All you have to do is type in the authors' names, and boom, presto, you have a PDF. Actually, you could have whatever format you want. They'll give you an HTML, PDF, Word doc, whatever you find useful. And some people have chosen to really spoof the system, to sting the system. This is basically a sting, to see if they could get it published, and lo and behold, they could. In fact, there's a sort of long tradition now, big tradition of stinging publishers. People try and get all sorts of stuff published, and often, unfortunately, they do get published. But the sort of fakery goes beyond even just, and again, keep in mind this publisher perish. To me, this is why all of this is happening. The fakery goes beyond just faking data, sort of publishing and publications. People fake data, which I'll get back to in a minute, but then they go far beyond that. And because of this publisher perish culture, it's now possible to create entirely fake resumes and fake, CVs, fake, Google Scholar pages, if you want to do that. This, I guess, would have been timely a few days ago. I hope there are no labs that have pumpkin heads working in them, but some might argue there are a lot of labs that have pumpkin heads working in them. This was a piece that Adam Marcus, my co-founder at Retraction Watch, he and I wrote for Nautilus, published about a year ago. And it starts off with, hopefully some of you I think will know this particular reference. It starts off with the story of Haas Cartwright. How many of you know Haas Cartwright? Yeah. I don't want to be ageist, but you kind of have to be ageist. Some of us may know it, some of us may not. He was a very well-known, beloved character on Bonanza. He worked at the Ponderosa. He was a cowboy, right? So what you may not have known about Haas Cartwright, even those of you who knew who Haas Cartwright was, was that he also is a very well-known scientist. Turns out he's an all-star virologist. And you know this because he's been invited to give talks at some very prestigious virology conferences. He's on the editorial boards, actually, it turns out, of several really key journals in that field. And of course, what you also know is that what I'm telling you is complete nonsense, right? And so there was someone named Burkhard Morgenstern. He's in the Netherlands. He's a researcher. And just like everybody else wanted to sort of sting the system, spoof a little bit, he created this whole fake persona of Haas Cartwright. And he gave him the name Haas Cartwright. He wasn't hiding it. And you can go online and find these CVs and what have you of Haas Cartwright. He put in some tells. So he put in a tell like his PhD, Haas Cartwright's PhD, was from the University of Dunno What. And he also put in that he was actually his PhD was in bovine studies, right? Which I suppose is true in the sort of University of Life idea. But what it also says, and it's a nice, clever little tell, is what was Haas Cartwright really an expert in? I mean, what do you get to, unfortunately, probably walk around a lot on a ranch? Scatology, that's another polite way of saying it, but if I may, I just don't know you all well enough, but, bovine excrement, otherwise known as bullshit, right? So, but yes, scatology is definitely the scientific way to talk about it, academic way to talk about it. And this sort of thing, and again, there's a serious issue here, which is that people are able to really fake whatever they want, and it's all because you have to get those metrics. I don't think I have to tell this audience that I heard a little bit before about patient satisfaction surveys, and you can game any metric you want. Any metric you want. So there's no reason to think you can't game these sort of metrics. There's also some pretty, and that's sort of maybe fun and illustrative behavior that people are just making to show a point. Then there's sort of some really bad behavior. This is from a column that Adam and I have in Stat News called The Watchdogs, but this was a column we wrote at the beginning of this year. And I'm going to talk about peer review a lot, so I hope you'll all forgive me, those of you who are very familiar with peer review. At different points, I'm going to sort of introduce different parts of it so that everyone's comfortable with the process. But the whole notion of peer review, one of the notions is you are doing this as a service. The fact that it's free service is actually some people are getting upset about, but you're doing this as a service and you do it confidentially, right? Because chances are pretty good that when you are asked to peer review a manuscript, you are at least in the same field, maybe even a competitor of the person you're peer reviewing. And you know full well, if you want to sort of follow the golden rule way to do things, that somebody else is going to that person's probably going to peer review you too. So there's a little bit of a balance on that. But you're supposed to treat this confidentially. This particular researcher decided that wasn't necessary. So this was actually based on a whole series of exchanges that happened that was published in the Annals of Internal Medicine earlier this year. What happened was somebody at Tufts, Robert Danziger, he submitted a manuscript to Annals of Internal Medicine, which is a pretty prestigious, sort of high, very competitive journal. So it got rejected. Things happened. I mean, he kind of expected it to be, is what he said. I mean, he thought it was great. His mother thought it was great, but the peer reviewers didn't. One of those peer reviewers who voted to reject this, it turns out, and several months later, published it himself. Not with Robert Danziger's name on it, oddly enough. So he published it in a journal that, by the way, turns out to be predatory, which is a whole other, there are layers of every story, as you know. So he published it, and Danziger sees it because it comes up in a search, in a sort of, one of his alerts about his field. He studied, this was actually about sort of diet, cardiometabolic risk factors, things like that. I think statins were involved somehow. So Danziger sees this, writes to the Annals of Internal Medicine, says, what the hell happened here? And they say, oh, wow, that's pretty interesting. It looks as though one of our reviewers, and normally they wouldn't reveal who the reviewer was, but this was basically criminal behavior. So they said, oh, one of our reviewers seems to have taken that and published it. So there's a whole exchange. This guy's name is Carmine Fanelli. He's in Italy, and it turns out he just had I think it was his fourth retraction. Not surprisingly, bad behavior tends to cluster in single individual people. So he's now had a lot. But here's, again, such pressure. And again, I don't want to condone his behavior and say, oh, it's just because of the system. Obviously, this is an extreme sort of thing to do, sort of act to take. In response to that pressure, most people don't do it, but this is what we're dealing with. Again, speaking of peer review, I'll stay on that theme for a second. This you may have heard of. This was a story we broke in, I think it was April or May, about a journal called Tumor Biology, which until quite recently was published by Springer Nature, is now published by Sage, which is in and of itself is an interesting story actually, but Sage Publishing, yeah. So they have this little bit of a history, it seems, or at least a habit of picking up problematic journals, and it's a little bit of a hero, sort of, if I had to read their minds, I think they honestly think they can save them or fix them. Whether they can or not is another issue. Anyway, so Tumor Biology is a basic science journal. Don't know how many of you have been familiar with it, but as it says on the label, they're about tumors, the biology of tumors. This journal actually had to retract more than 107 studies, all at once, which, we like our records, which I'll get to in a second at Retraction Watch. This was actually a record on two different records. They broke 2 records at once. I don't know, the Olympic sort of metaphor there, but number one, that's the most retractions we've ever seen at once, right? And number 2, in fact, it's more than double the number of retractions you'll see in a second than there were in the year 2000, for example. And number 2, it's the most retractions by a single journal ever. So in other words, no other journal has more than 100 retractions, it turns out. Now, what actually happened here? Well, here's what happened, and we sort of like this story. I don't mean we think it's a good thing in the world. We like it because we're journalists and we like to find out bad things in the world. So again, peer review is supposed to be, as it says on the label, peer review. It means a peer reviews it, right? It is not supposed to be that you review your own paper, which may be the dream. In fact, probably is the dream for many people. But is not supposed to be how it works. My students don't get to go and log into the NYU grade system and put in their own grades. Some of them will probably figure out how to do that one day, and I'll be really screwed. But that's actually not what's supposed to happen. So, but here's how it happens, and you say, well, how does that happen, right? So that's not what's supposed to happen. How did someone do that? Well, and by the way, there were 107 at that point. There actually have been more than 500 retractions for fake peer review since 2012, when we first reported on the phenomenon. You may have seen a story a couple weeks ago now in the New York Times, front page story. It cited us actually in the second paragraph for the fake peer review data, because we have it. We're the only people, because we're sort of geeky like that. But that was all about China, and all of these 107 were actually all from China. But here's how this works. So I submit a paper. Well, actually, make me the editor. I'll be the editor today. Kevin's he's submitting a paper, right? And, Kevin wants to get it published because he's got to do that to advance and do whatever and get grants and whatever else. And so he submits the paper to my journal, and one of the things my journal asks him to do, which is not unusual, is to suggest some peer reviewers. Because maybe I don't have that many peer reviewers who have the expertise that I need to review Kevin's paper. So although it actually opens, obviously, a vulnerability, which you're now hearing about, and some journals, by the way, use that simply to say, well, if Kevin wants that person to review the paper, I'm going to have anybody but that person review the paper because it's probably his buddy from med school or something like that, right? But okay, so I'm not that person. Today, I'm like, Kevin, and he recommended that Jane Smith at Harvard review the paper. And I look at it and I'm like, oh yeah, Jane Smith. I remember seeing her. She did a great job at that last conference. It's really interesting data, and I thought, wow, it'd be great to get her on my peer review panel, my group of my database. There's a great opportunity. So I click on, send an email to Jane. My system sends an email to Jane Smith and says, please peer review this paper, et cetera, et cetera. And Jane is, of course, happy to review it. She writes back and says, yes, I'll review it, and she does a review. So far, so good. Here's the part of the story that you maybe guessed, but don't know yet because I haven't told you. The email address that Kevin provided for Jane Smith was not janesmith at harvard.edu. It was jsmith123@gmail.com, right? And who do you think actually controls jsmith123@gmail.com? None other than our terrific host, Kevin Kavanaugh. Now, Kevin is actually getting the invitation to peer review his own paper, which was what he planned and which he's delighted to do. Kevin writes a review of his own paper, which, sort of like cheating in any other area of life, like you want to psych people out, You don't want to just say, fantastic, approve, accept this paper. What you do is you write a very sort of thorough review about the various problems that Kevin probably put into the paper himself, so that he would have something to say in this review. But if Kevin fixes all this stuff, I think we should publish it. Now, you're thinking, that's great. Like, why doesn't it work? And it did work at least 500 times. In fact, probably far more than that. But the reason you're hearing about it from me is because those 500 were retracted, and now there are checks and balances in place. And the way that Kevin, or in this case, in the very first case, someone in South Korea was caught, was because they were overeager. And what they did was they returned all the peer reviews within 24 hours. Now, any of you, it sounds like there's some journal editors or people who work with journals a lot in the room, because you know that you can't even get people to accept an invitation within 24 hours. You certainly can't get them to actually review within 24 hours and write something thoughtful. So when they contacted the person in South Korea, he actually confessed, and that's how we were off to the races with this. But more than 500 papers have now been retracted for fake peer review from the literature, and we think that's pretty significant. Speaking of some numbers, though, I just want to share with you, these are actually pretty much brand new, because our database, and that's our database, which I'll show you on the next slide, retractiondatabase.org, thanks to some terrific, generous funding from various foundations, which I'll mention at the end, we've been able to create this database of retractions that heretofore has not existed. You would think it would exist because between all the indices we all use, PubMed, Medline, Scopus, Web of Science, you would think that you could gather all the retractions in one place and have a comprehensive list. And if that were so, trust me, I would find lots of other things to do with my life than create this database. And I guess I had the idea and I raised the money, but the person who actually did it was our full-time researcher, Alison Abritis. I want to show you, though, some data about this that are going to tell you, I hope, a little bit of a story. And again, it may be hard to read, but and these slides, of course, will be available, and the database is freely available. But in the year 2000, there were 30 retractions, and there were about 1 million papers published. And I do want to say, I want to stress that the denominator is really, really critical here, because I think people tend to look at this rise in retractions, which I'll talk about in a second, and they say, oh, wow, that's dramatic. It actually is pretty dramatic, but it is far less dramatic when you consider how many papers are published. Again, I would liken that to the adverse events reporting database. The adverse events are incredibly important. That's why they're studied. That's why they're the source of so much great information. But you always have to look at what the denominator is, and also have to think about whether you're catching all of them, which I'm going to, of course, talk about in a second. But you can see that there's been a sort of slow rise in the number of papers published. You would therefore expect to see the number of retractions rise. And I'm going to come back to the year 2000 because it's kind of a big honkin' outlier. But if you just look at all the years other than that, the percentage of retractions on the right, so it went from 30 to 332. This past year, obviously 2017 isn't over yet, but this past year we're 1,305. That means that between 2000 and 2016, the number of retractions went up more than 40-fold. More than 40-fold. The number of papers didn't quite double. Maybe doubled, depending on the database. But let's say that it doubled. 40 times, you would expect maybe twice. You're getting 40 times. It means you're sort of 20-fold increase, 20-fold rate of increase more than you would normally expect. And again, as a rate of papers published, it's pretty small. These are percentages, but again, it's 0.073%. We're not talking about 7%. We're not talking about even 0.7%. We're talking about 0.07%. But it is increasing. I'm going to talk in a minute about how large the number really should be. But I actually just want to go back to 2010, which, as of 2011, we all thought that there were about 400 retractions in 2010. Nature magazine did a fantastic job sort of showing that trend and showing that even if it was only 400, it'd be a really significant increase. The reason why you see, though, close to 4,000 retractions is that, and I think this is indicative of some of the issues that we're dealing with retractions, is that they're not well publicized. And until about a year ago, we thought, again, that the trend was sort of going along. It turns out between 2009 and 2011, a publisher called IEEE, they're electrical engineers, computer scientists, they actually retracted 6,500 papers, 6,500 conference abstracts. And now, while in biomedicine a conference abstract is just a conference abstract, you would then have to publish it in a proper journal. Conference abstracts in electrical engineering and computer science are the thing. They actually are considered the papers, because they are. They're actually the whole paper. And it looks actually a lot like fake peer review, but we want to be cautious there because the retraction notices, as I'll get to in a second, are really unclear. But so that actually completely warps our understanding of this. I mean, it's like, well, wait a second, we now had this huge bump. So it's not that we reject those data. We actually think they're really important, but we're always very careful to say it's not that you had this massive spike and then everything's coming back to normal. Those years are just inexplicable. And again, by the way, that's one of the reasons, one of the significant reasons why our database is unique and doesn't exist anywhere else. Those don't appear in any database yet. They now appear in ours. But if you think about it, so we think there are about somewhere between 14 and 15,000 retractions ever. That goes back to the 1970s. Among millions of papers published. We used to think there were maybe 6,000 or 7,000. If you go to PubMed, I think you'll find right now between 5,000 and 6,000. But again, we're looking at all of science, and we're also giving actual reasons for the retractions, which I'll get to in a minute, are not there. And just you can't, I can barely read that, so none of you can, but this is our database. There's a pretty prominent sort of version of this is in beta at the top, just to be clear, and I want to make sure everyone knows that. But if you want to find, you can search by any criteria you want. Obviously, author, country, journal, reason for retraction, when, date, et cetera, and when there's coverage on Retraction Watch, retractionwatch.com and retractiondatabase.org are separate URLs, even though we're obviously joined with apologies to our speaker, Dr. Tower. We were joined to the hip, so to speak, but titanium, I think. But this is our database. You can go there right now if you want, if that would be more interesting than listening to me, which it very well might be. That's retractiondatabase.org that we're building. And we'll be basically finished with in a couple weeks. And when I say finished, obviously there are always new retractions every day. I say finished like we're complete and comprehensive up to that day. We have not quite been there yet because we've been adding thousands of them for the past couple of years. So let me run through some common reasons for retraction, because I think this may be instructive for those of you who think about the literature or want to think about the literature. So first is what's known as duplication. Now this is sometimes referred to inelegantly and technically incorrectly as self-plagiarism. You can't actually plagiarize yourself. The definition of plagiarism means you can't do that. However, it precludes that. However, you can duplicate your own work, try and publish it more than once, or twice, or in some cases 5 or 6 times. That is considered the very best a copyright violation, or the very worst a way to sort of give yourself credit and what have you that you shouldn't actually deserve. That's responsible in one series for about 15% of retractions. There's good old-fashioned plagiarism, right? I hope I don't have to describe what that is, but that's about 10% of retractions. Image manipulation. Again, not all that relevant to clinical retraction or clinical study retractions. This kind of image manipulation is in basic science. And some of you are probably familiar with something called Western blots, where you have a bunch of cells or blood or something with a lot of proteins in it, and you want to figure out, I'm oversimplifying here, but you want to figure out what protein is in it and how much, and then sort of how big the proteins are. You basically shoot them all into a gel, sort of agarose gel thing, and well, that'd be a different thing. Anyway, you shoot them into a gel, into these little wells. You shoot that full of electricity, and they all separate based on what you're looking for. Again, I probably oversimplified and got a little bit of that wrong, but that's the idea. But the point is that what you end up with is this sort of nice-looking square with bands in it, like little white bands on a black background. And maybe that day you just don't think that result is the one you should have gotten. Like there's a weird band up here, and you don't like that band because it sort of doesn't fit with your narrative. It's like if I just ignored the fact that there were 4,000 retractions in 2010 and said, that's an artifact. So I go into Photoshop, because I can do that, and I just black it out, because trust me, I know better. Or I forgot to run a control that day, which people do. The controls are always the same. It's a protein called actin. It's like a ladder of protein. I'll just sort of cut and splice that from my old experiment and throw it onto this new experiment, and that's fine, right? No, okay? And nowadays we can find all that, and I'll get to how people are finding all that, because Photoshop allows you to, you can commit you can commit fraud with Photoshop, you can then actually detect the fraud with Photoshop. There's good old fake data, good old-fashioned fake data. I'm going to get to a leaderboard of people with the most retractions in a little while, and you'll see that most of those people, they've actually gone out and faked the data. The federal definition, and the U.S. federal definition, which is kind of shared by most countries at this point, is of misconduct. Scientific misconduct is falsification, fabrication, plagiarism. Again, we've done the plagiarism thing. Falsification is what I was describing with those Western blots, like making your results look better than they actually are. Like you did the experiment, but it didn't come out the way you wanted, so you're beautifying it. And then there's fabrication, which means making it up. It's a little tricky though, because in science you actually want to falsify your hypothesis. So it can get a little confusing for people. Like, what? Falsification's bad? Well, yeah, of a certain kind. But that's fake data. I've talked about fake peer reviews. Publisher error is just an annoying thing that honestly is not terribly important. But when you think about it, publishers should, let's say that they publish a paper 2 or 3 times, their fault. They just pressed approve or whatever a few too many times. Fine, they should do something about it in the scientific record, but they shouldn't make it look as though the researcher was responsible, which is what a big honkin' retraction notice says. It's sitting there in your automated CV, which a lot of universities use, right? So you want to, we think there should be another way to deal with that, but it's not terribly important. Authorship issues are really thorny and ugly and terrible, and people fight over this stuff, and they actually go to court over this stuff sometimes. We see people who are on papers who shouldn't be, sort of ghost or guest authorship, honorary authorship. We see people who aren't on papers who should be, right? Sort of both varieties. And then we see people, like I was saying with the fake authors and things, having a little bit of fun with it. Some people, there's one guy in particular. How many of you speak Italian? Anyone speak Italian? No one speaks Italian? Oh, I see someone speaking Italian. Okay, all right. So you sort of fact check me, and also actually I should say this. You will hopefully be deeply offended what I'm about to say because you'll understand it, but I don't mean to offend you, of course. So there was an author, and this again, every story has lots of layers. There's an author he's a physicist, and he was convinced he was right about his theory, and he just every time he tried to publish it in the top journal in his field, he just couldn't. He couldn't publish it. They just kept getting rejected, and he kind of had this idea that maybe it's because he wasn't at a prominent enough institution. So he said, I bet that if I submit this paper with a co-author with a really prominent institution, I bet that it'll get published. He says, okay, all right, fine. So he picks an institution in Italy. He doesn't want to like actually use someone's real name because that would be another layer of fakery that he wasn't comfortable with. I mean, but he was trying to spoof the system. He was very open about this. But he picked an author at this very prestigious university in Italy, a physicist, and he gave him a name, right? And so sure enough, he submitted this paper. 3 of them got published, like that. It was just same exact paper, changing the date basically, and look, it got published. So he was right, but he wanted everyone to know this. So same with Haas Cartwright, same with all these sort of fake stuff, IP Freely, all that. So he wanted someone to know this. So he picked a name that anyone who speaks Italian would, or at least reads Italian, looking at it on the page, would see was kind of obviously kind of a little bit of a dig. And so he picked a name, and my pronunciation I think is right, but my translation may be a little bit unclear. But the name was Strancio Bestiale, right? Which basically means, correct me here, giant, and then I will not say the body part, but let's just say that, and lots of clinical people in here, so I hope you actually can answer this question, but or think about what I'm saying. Giant body part that everyone has, everyone in this room has. I mean, if you don't have one of these, you really need to see a doctor, but things are backing up, let's just say that. So anyway, he picked a name that was giant, etc. And, right, does that kind of work? Yeah. I don't say the body part A because of the translation thing, because it's kind of offensive, and this is being recorded for legal reasons. I'm going to talk about this in a little while, in the remaining time, about the fact that lawyers are getting more and more involved in retractions, in scientific misconduct. As with everything, that's neither a good nor bad thing. It's great for us as journalists, I'll tell you that, because when lawyers file lawsuits, and you all know this because of the work you do, but lawyers file lawsuits, all of a sudden there's a hell of a lot of material that is publicly available that I didn't have access to before, and that I probably would have had to sue in order to get, and now I have it. So people who are thinking about filing lawsuits might want to think about that. And then finally, a lot of you may have heard about the sort of what so-called reproducibility crisis. I'm not sure I like the word crisis, but the fact that, and John Ioannidis at Stanford and some others have done a really great job of highlighting these issues, the fact that something like 50% of, and this does include clinical findings, 50% of findings in the scientific literature, in the biomedical literature, seem to not hold up. They're not reproducible. That's obviously a massive problem. It's a hell of a lot bigger than the 0.02% I'm talking about, 0.07% of retractions. So there's some big gulf there we got to deal with. And the question is, what should we do with all those papers? Should we retract them? I'm going to talk in a second about what the criteria for retraction are. But I don't necessarily think they should all be retracted. And by the way, it's not just because we already have enough to keep up with 1,300 retractions a year. It's just because I don't think retraction is necessarily the best mechanism to deal with that. But should they all have notes on them? Should they have some kind of editorial, just notifications without a judgment call on fraud or anything else? Probably. Okay. Just to give you a sense of why retractions, I gave you a list of reasons. Now let me quantify that for you. About 2/3 of the time, according to this paper that was in PNAS in 2012, 5 years ago, about 2/3 of the time retractions are due to misconduct. Again, that definition of FFP. By the way, since there are plenty of clinical people in the audience, I will say, as an aside, when I first started looking at this issue, and I trained as a doctor, although I don't practice and have a license, but I trained as a doctor, so FFP to me meant fresh frozen plasma. And that particularly resonated because when I was a med student at Bellevue Hospital in New York, I was the one who had to run down to the lab and match the blood type and all that stuff. That's what fresh frozen plasma, that's what FFP was to me. It's all I ever knew FFP to be. And so when people started talking here, and I was just learning everything like everybody, wow, FFP, like, wow, is there some huge scandal in blood transfusions that I don't know about? Like there's all fraudulent and there's all, wow. And I was like, wow, I found a big story, and then no. But anyway. So I think that, again, just like with, and apologies if this is not a good analogy, but I'll use it with the caveats. I think just like an adverse event reporting database, you have to sort of assume that you're not catching everything. And here's a good example. This was a Nature comment piece in Nature last year that showed that, in fact, when this particular group of nutritionists went and found really clear, like so clear that I could see them easily, statistical errors in 24, 24 different papers, and they went to the journals with very carefully worded, like not screeds, not personal attacks, nothing like that. Dear sirs and madams, this paper has a big statistical flaw in it. Think something should happen. They only heard back from 8 of them, and those 8 did something, correction, retraction, whatever it was. Only 8 did anything. So even if you use that, again, it's a tiny data set. But clearly, what is happening here is journals are not that interested in correcting the record. And I can assure you that that's true based on our experience at Retraction Watch. And again, just another slice of data, another way to look at this is, Elizabeth Bick, I mean, there are 2 other authors on this who are both great, but Elizabeth actually did all the work. Dr. Bick is, she studies the microbiome. She used to be at Stanford, now she's at a company called uBiome. She did a Herculean sort of heroic task, which was that she looked at 20,000 different papers. If you think, on her nights and weekends, if you think that sort of obsessing about retractions is just a little bit weird, she makes me look like a totally, well-adjusted individual. But I mean, she actually is a well-adjusted individual. Whether I am or not is another question. So what Ellie's found was that 1 in 4 papers out of these 20,000 had problematic figures, and half of those, so 2% of all papers in this pretty big data set, pretty big series, had inappropriate manipulation. So in other words, something that wasn't just like, that's a little weird, but something that looked like there was some intent behind it. That would be a 2% retraction rate if those are all retracted. So again, we're clearly not finding everything. I won't read this slide to you, and there's I'll just give you the punchline. This was a paper that Danielle Fanelli, who's now at Stanford, actually working with John Ioannidis, he did about, I think, 2009. It was in PLOS Medicine. And he did a sort of meta-analysis of all the surveys of how often scientists admit to committing fraud. And what he found was that 2%, there's that 2% figure again, admit anonymously to committing misconduct if you ask them. Of course, if you ask them, well, how many of you have seen other people commit fraud, then the number goes up to 72%. It's not me, it's my neighbor that tree is falling on their side, whatever. So I think that, and again, what the real number is, who knows, but even if we just sort of start to think about this 2% figure, which, by the way, when I've talked to people who study other fields of human endeavor, this 2% figure, like police, for example, police misconduct and what have you, the 2% seems to sort of follow us around a little bit. But again, it's much more than 0.07%, so we're not catching them all. So I promised you, and again, I don't know if you can read this, but I promised you that the lighting's here a little bit dodgy, but I promised you to sort of look at who retracts the most papers, and here's where clinical medicine will come into the fold a little bit. We keep a leaderboard of the people who've retracted the most. They're clamoring to get into it. I think that people want to be on this list about as much as they are clamoring to get into a cemetery, but that's another story. So the person on top has 183 retractions. We go down to 30, just arbitrarily, to go down to 30 people on the list. It's actually 31 now, for a reason that'll become clear in a second. In order to get on the list, just even at the bottom 30, you have to have, I think it's 16 retractions now, which is kind of a lot. Again, when you think about it, in 2000, there were only 30 retractions. Now we have individuals with 183. Number one and number two, they're actually both anesthesiologists. And Fuji's in Japan, Bolt is in Germany. Neither of them is doing research anymore. It gives me sort of far more trust in anesthesiology than in many other fields. And the reason is that I know that there are actually that many retractions to be had in every field. Anesthesia is the only field in clinical medicine that I can tell that's actually doing something about it. And that's because a lot of anesthesiologists, as you all know, have been very active with patient safety. And similarly, they've also been very active in cleaning up the literature. So there's a bunch of editors led by a guy named Steve Schaefer. He's at Stanford now. He's on our board of directors at Center for Scientific Integrity. He got a bunch of editors together and said, we have a problem. And it is incumbent upon us to push back against universities and to tell them, you'd better fix this because you're the ones with the power to do that and to investigate. And as a result, you're seeing lots of cases, including, he's actually no longer in the top 10, a guy named Scott Rubin, who used to work on Celebrex before he ended up in jail for having faked all sorts of data. And actually, the reason he ended up in jail was because he submitted Medicare claims for people who didn't exist, which just by the by is not a good thing to do in case anybody was thinking about it. Anyone who can see this list, notice anything about the demographics of it? I don't know if anyone can even see it. Yeah, there's no, normally I like no light there, but there's these lights that are competing. There are not a lot of American names, there are a couple.
So read it.
I'm not going to read the whole, no, it's just, so.
Asian names?
There's some Asian names. Anyone see any women's names on there? The answer is no, just in case. So there are no women on this list. In fact, you go all the way to the bottom, you go all the way to the 30, there's only one woman on the list, and she's actually number 30. Well, 30 and 31, she's tied for that, so who knows which number she is. And there's some interesting literature now on whether or not women and men sort of retract at different rates. It's very clear that men retract at a higher rate. It's also very clear that men are more just overrepresented in science, so that sort of follows. But it's unclear whether or not there's actually something to it. It is a data point, though. You can interpret it however you want. This is a look at which journals retract, and it's based on impact factor. And impact factor is quite controversial. I don't want to sit here and defend it. But as you know, it's sort of the rate at which typically, or on average, journals are cited. Papers and journals are cited. And it's against retraction index, which is just the number of times it's a rate of retraction for different journals. Now, what you will see, if you can see this, is that it's an almost linear relationship between impact factor and retraction index. So New England Journal of Medicine, way up at the top, has both the highest impact factor and, in fact, the highest retraction rate. Cell and Science and Nature, which are sort of their NEJM's equivalent in basic sciences there. The Lancet is off to the left doing its own thing, which, quite frankly, the Lancet's often off to the left doing its own thing, but that's a little comment. But why is this true? Why would it be that journals with the highest impact factor are, the sort of most prestigious journals, are actually having the highest retraction rate? And there are at least two sort of conclusions you can draw from that, the same way you can from the increasing retraction rate overall. One is that people are committing more fraud in those journals, the same way they're just committing more fraud, maybe, and we don't know if this is true overall. But the other is that they're better at catching it, or that there are more eyeballs, so the rest of us are better at catching that in these journals. And one would hope that journals that are cited more are actually read more. It's not clear, actually, that that's true, but in any case, that's something to think about. But here's a little more serious issue, which is, and I'm going to show you, this slide is the 2011 replication of this particular study, same authors, some of the same authors, of a 1999 study that appeared in JAMA. The punchline of this is that what happens with retracted papers is if you look, once they're retracted, a number of them continue to be cited, and more than 90% of the time, they continue to be cited as if they had never been retracted. Now, it's okay to cite a retracted paper. I'm going to show you some examples on this next slide of papers that are cited for good reason, because they're retracted papers that are cited for good reason. But you shouldn't be failing to note the retraction. That's a problem. Again, some of you, I think, are attorneys in the audience, and you will understand from shepherdizing, right? If you show up to a courtroom and you cite an overturned precedent in terms of your case, and you don't mention that it's been overturned, in fact, you just shouldn't cite it at all, but you don't mention it's been overturned, you're going to lose the case, and the judge could actually sanction you if he or she thinks that you knew about that. You will not be able to read this because I can't even, but from this distance. But what this is, we have another leaderboard, and all of this is available on retractionwatch.com, by the way. These are papers that continue to be cited quite a lot after they've been retracted. And number 2 on the list is actually Andrew Wakefield's paper from The Lancet alleging a link between autism and vaccines. It actually has been cited far more. Again, mostly people say this has been retracted, so that's good, since it's been retracted. Part of the problem and part of the reason that we created the database is that we want everyone to know when a paper's been retracted. You can choose to cite it, that's fine. I'm not going to tell you what to cite and what not to, but you should know that it's been retracted. And part of the problem, according to this paper, is that journals actually don't tell you when something's been retracted. You can get to go to Medline, go to PubMed, go to the journal site, and you end up not knowing that the paper's been retracted, about a third of the time. One hopes that this has changed since this paper was published in 2009, 2010, but that could explain why a lot of people don't know. So what we want is for people to hook our database up to Mendeley or EndNote or whatever you use to publish, to keep your references, so that you'll get a little ping whenever something's retracted. And if it is, you decide what to do with it. Here's my chance to see if any of you are clairvoyant. How many of you can tell me why this paper was retracted? This is not a clairvoyant crowd. Kevin, you promised me some mind readers here, and I'm really very upset. So it turns out that this paper, and this is a typical retraction notice of many journals, fewer now, thankfully, but a typical retraction notice, it turns out this paper was retracted for fraud. We learned that, even though the journal didn't want to tell us, because we have a lot of readers in Japan. It was a Japanese researcher. There was a news story about this person from the few months before. It turned out that this person, I'll sort of tell the short version of the story is, not only had he been messing around with his data, he had gotten a grant to do cancer research, but why it was in neuroscience is a long story, but cancer research, he had taken that grant and instead studied hair loss treatments, which he was marketing. Now, personally, I happen to think hair loss treatments are really, really important. I do not, however, think they're more important than cancer research, nor do I think you should fake a grant like that. And part of the reason why, I mentioned lawyers a little while ago, and I'll just mention them briefly again, is that you're seeing lots more lawyers get involved with this process. Now, I believe that everyone deserves the most vigorous defense imaginable. I really do that. I really do. However, I don't believe that the scientific record should reflect a particular spin based on legal advocacy. I think the scientific record should say what it says based on what's true, or what we think the closest thing we can get to the truth. Unfortunately, though, and Nature was very clear about this, they hear from lawyers immediately. One of the few sort of laws where I think that the U.S. is more progressive than many other countries is in terms of libel, at least until this point. We see some threats to that. But libel and defamation, truth is a defense for libel. It's actually why it's much easier for Adam and I to do what we do in the U.S. than elsewhere. But Nature gets threatened with lawsuits, and they, at the very least, they're going to have to pay a lot of money to defend themselves, even if they win. So lawyers are getting more and more involved. I will say at least one journal, actually a number of journals, have changed their policies. Remember, one of the reasons we launched Retraction Watch was because so many notices were opaque. They were not transparent. And I've bolded this, but it's just basically what this says is Journal of Biological Chemistry said, we're tired of hearing you guys beat up on us. They actually hired 4 different image manipulation specialists now, which is great. So if Adam or I ever run for Congress, we can stand up and say that we were job creators, which I guess is what you're supposed to say. There are rules and sort of not rules and not regulations actually, but guidelines for retractions. If you're interested in these issues, the Committee on Publication Ethics, they're sort of they're the top notch. They're the top of their game. They've been around for more than 20 years now, and they've got guidelines on what should be retracted. And I want to just highlight this for a moment. and I want to finish up here to get us to lunch, of course, but I want to just highlight this for a moment. Retraction is not necessarily the best, most appropriate way to deal with a problem in the scientific literature. We happen to think it's a really important one, and we happen to think it should be used more, but it's not necessarily the most important way, and we need to sort of deal with that. Very briefly, in the last few slides here, I want to just sort of talk about one site that I think I would love it if more of those of you in this audience were familiar with and used and commented on, and that's called PubPeer. It's pubpeer.com. You can go to PubMed Commons also, but there's some limitations on who can comment there. PubPeer allows you to leave comments on any study that has anything like a digital object identifier. If it's published pretty much and it's worth looking at all, it's going to show up on PubPeer. And this is just one example, but you can leave comments, you can be critical, you can't be personal, you can't libel people, but you can say, this image looks like this other image, would everyone like to take a look? And guess what? That has actually led to a number of retractions and corrections. PubPeer is funded now by some of the same folks that fund us, the Arnold Foundation, which we're really delighted about because we think they should grow. And one of the things that hasn't happened yet is a lot of uptake among clinical researchers, among people who look at clinical studies. So what you'll see mostly is, this is just a little bit about PubPeer and why they were created. What you'll see mostly is preclinical research. So I would urge you, if there are papers you care about and think need to be scrutinized, even if you want to say something positive about them, get on PubPeer, leave a comment. You'll be amazed at what kind of conversations happen. That's just a bit from Brandon, the co-founder. I promised you, and it'll be short, but I promised you a little bit of the story of Yoshitaka Fuji, because I think it's illustrative of what's happening in a couple different arenas, and it is very much about post-publication peer review. So Fuji, you may recall, was the #1 retraction record holder. He's got 183 retractions. That record, although I am always loath to say things like this because I'm always wrong within 6 months, that record seems pretty stable. It doesn't seem that anyone's going to break it anytime soon, but we'll see. So Fuji, as I mentioned, was an anesthesiology researcher, and people started raising questions about his research actually back in 2000. And so somebody published a letter saying these results are sort of too beautiful. I don't believe them. And so Fuji wrote a letter back saying, oh, thank you for your concern, but they're fine, thank you, blah, blah, blah. And the editor sort of let it go at that. But Fuji, he then knew that the reviewers in anesthesiology research were onto him in some way. Even if they hadn't retracted anything, they were onto him. Excuse me. So he started publishing in other journals. And by the way, people do this, right? They venue shop, right? That's what they're doing. They're shopping. So he realized he could go to like a pediatrics journal, which would be delighted to have some anesthesia research in it, because it's interdisciplinary and everybody's got to be interdisciplinary now. But that the researchers, the reviewers wouldn't know anything about how to review his papers properly. So he gets all these papers published there in ophthalmology, because remember, you're doing anesthesia, you do it on any number of populations. He did OBGYN, like everything. Got all these papers published, got to 249 papers eventually. Then there's this guy named John Carlisle, little stick-in-the-mud guy in the UK. Anesthesia researcher, self-trained statistician. He says, something bugs me about all of these papers. I don't like them, right? There's something, the data just they smell funny to me. So we subjected them to a fairly rudimentary statistical analysis, which, to put a caveat on it, other people have questioned, not so much that it's wrong, but that it needs some finessing and some nuances. And he found that the likelihood that all these data were true, in other words, he basically did something, some of you may be familiar with, something called Benford's Law, which basically is a way to look at what is the likelihood that a given data set has the variability that you would expect if it were real, right? I mean, if it's big enough, it should have a lot of variability, even if it's small. We're not very good at faking data, it turns out. Much worse than we think we are. And we don't have enough randomness when we fake data, just in case anybody's sitting there thinking about faking data. So he brings this to all the journals, he brings it to the university, they say, you know what, you're right, Dr. Carlisle. And then lo and behold, he's got 183 retractions. And some people say to me, one of the questions I always get about 183 retractions is, wait a second, how do you get to that many retractions? Like, what is it? You have 1 or 2, and everyone's like, oh, thank you for correcting the record, be careful. You have 9 or 10, like, oh, maybe you should look for a position elsewhere. And then your dean comes to you and says, listen, if you get to 182 retractions, that's okay. But at 183, I'm going to have to ask you to leave. That's not how it happened. They all happened at once. So I just want to mention briefly some of the fallout, some of the actually consequences of retractions and of misconduct and fraud. A lot of you are probably familiar with the False Claims Act because it's been used to go after pharmaceutical companies, drug companies that are doing off-label marketing, for example, and it's very useful there. But it's now being used to actually go after universities, and maybe sometimes individual researchers, but more likely universities, who commit misconduct, where the researchers commit misconduct. This is a case of Piero Anversa. This just happens to be Brigham and Women's Hospital and partners up at Harvard. And they actually settled the case for $10 million recently. It's worth checking out. The idea here is that if you make a false claim on a grant application, it is like making any other false claim to the government, and you are therefore liable. Again, very brief non-lawyer version of the False Claims Act. There are treble damages, and the whistleblower actually gets a pretty nice chunk. And so there's an incentive for people to do this. One of the other things, though, that's happening is that, and this is very, very small numbers. I mentioned Scott Rubin going to jail. This is someone, he was actually spiking his rabbit blood. He was studying HIV vaccine, a potential HIV vaccine. He was spiking rabbit blood samples with human blood that was his control group. And so how he came to do that is actually fairly interesting. The whole story is very interesting. All these stories are interesting to me, but he's actually serving more than 5 years in prison, almost 5 years in prison. Some of you, probably most of you, have heard of this guy named Chuck Grassley, who's the senator in Iowa. And Chuck Grassley took a very active interest in this case, which somehow the U.S. attorney in Southern District of Iowa decided meant it was worth paying attention to. And I would actually argue this is far too much time that he's serving. I'm not saying he doesn't deserve punishment. But A, he confessed, which is actually what you want. And now no one's going to confess, right? Because no one else has gone to jail. And number two, when you compare it to other penalties that people have faced, you want to talk about 6 months in prison, a year? I mean, let's talk about that. But 5 years, when you consider some of the really, really bad stuff that people do, they don't go to prison, I don't know. But if crime doesn't pay, doing the right thing does. And this is maybe a little bit too Pollyannish, a little too optimistic. But it turns out that when you retract a paper for honest error, which we encourage people to do if there was an honest error that they catch, nothing bad really happens. The scientific community basically looks at that and says, and I say unconsciously because in their citation patterns, you don't see a decline in the number of citations to your work. I don't mean just that paper, but I mean to all your whole work. If you retract a paper for fraud, and it says that clearly in the notice, then you actually see a dip in your citations overall about 15%, if you need any reason not to commit fraud. And so I would argue, hey, let's all encourage people to do the right thing and actually, the same way we have with, medical safety, right? So, hey, there was a mistake or there's something bad happened, somebody should be allowed and encouraged and empowered to say something bad happened. And I'll just leave you with this. It's, I think, a really good quote from a paper that came out, a survey of sort of what's really going on. We talk about fraud, we talk about misconduct, we talk about very clear, honest error. There's a whole, getting back to that original premise of publish or perish, we have a system that is, at the very least, not discouraging bad behavior. And we need to really deal with that. We need to deal with the incentives, which are all about publishing papers. So that's, again, it's an interesting paper that Lex Buder and some others did. And I should leave you with that. Just if you want to contact me, or there's also our very generous foundation support. So thank you all. And I don't know if there's time for questions, but Kevin's probably going to tell me.